One of my viewers asked me if I would watch this video, and I thought it sounded very interesting. Building a house, and this is in Germany, I believe. Part 2, masonry. So this must be the masonry process in building a house in Germany. German technology, house construction documentary. So yeah, I wanted to see how it compares to what I know with the building of British houses, which is, I feel like in the UK, I don't know if this is universal, but a lot of the older houses are built to last, built to withstand the test of time. Like, they're built very strong, built very good. But a lot of the modern houses seem to use cheaper materials, cheaper building processes, and they're just not of the best or similar level of quality. I guess you could say that about a lot of products these days, that a lot of people just want something cheap, and that in turn means the quality is not so good. But interested to see how it is in Germany. If they're still building strong houses, let's watch and learn.
How is a house built? How does that work? We accompanied the complete construction of a typical German single-family home for more than 6 months. We were involved in every important step, from the first floor work to the finished house. In the first part, the earthworks were carried out and the floor slab was cast. Now the masonry work continues.
Yeah, I think even with that, when you see like houses, from what I know, here in Malaysia, sometimes in America for sure, there's a lot of houses that have like a basement. Is that ever something that's built in Germany, in modern houses, older houses? Is it just not the culture there?
The floor slab has hardened and the bricks are already there.
Strong foundation.
Now it can start with the masonry. The first step, lay bitumen membrane. It protects the walls from rising damp. For the first row of bricks, a cement mortar has to be mixed, which later becomes as hard as concrete. It serves as an underfill to compensate for differences in height of the base plate, because the stones must all be at exactly the same level. It starts at the corners. A laser checks whether the height is correct.
Yeah, just one thing I wanted to say about this specific development. This looks like it's just a single house that's being built. Is that common? Is this just someone who's bought a piece of land and has built their own house on here? I know in Australia, for instance, that's something that's quite common, even today, that a lot of people just build their own house. How much would something like this cost? But do you also have like big housing developments? It's those houses where it's all like similar houses, just built cookie cutter type houses. That's mostly what the new builds in the UK are. And would you see any difference between the quality of those types of houses compared to something like this, which was just building your own house?
If the first stone sits and is exactly in balance, the next ones are aligned with it. In the other corners it happens the same way.
And I don't think I've ever seen bricks like this as well.
All dimensions for wall openings, for example for windows and doors, must also be observed. The masons have the floor plan for this. Here on the south side of the house there is already the first special feature, 3 floor-to-ceiling windows. The row of bricks must therefore be interrupted here, just like on the front for the front door. The first row is slowly taking shape. The masons work their way from the corners and put stone by stone. But what kind of stone is that exactly, which is installed here?
We do not work with the external wall insulation system, which is widespread here. Instead, our houses use a so-called Puritan stone, so that's a stone made of clay, in which the thermal insulation is integrated in the stone, with hydrophobic mineral wool. Sew a solid stone, 36.5 centimeters thick, with hydrophobic mineral wool as insulation.
Yeah, so again, I don't know if this is like an advert for this company or what, but you see this is not common. So I guess it isn't common with that built in. Like how does this insulation compare to traditional insulation? Is this better? Is it more efficient? Does it actually work? Yeah, again, just like looking at the people building the house with regards to like the people who build houses like this, do you find it's always like a very good quality? Is it always German workers that are doing these jobs? Again, like comparing to the UK, a lot of these modern cookie cutter housing developments have a lot of problems when people move in. Like you have like this period where they can rectify the issues, but they build these houses with issues already, like, and people have to spend a long time getting them fixed. Is that ever a problem in Germany?
That means best sound insulation and best building physical properties and also the best thermal insulation.
Okay, is that true?
The bricklayers have made the first course and are already on the second row. So-called thin bed mortar now ensures the non-positive connection between the rows of stones. Ideal for energy-efficient building. High load capacity with a very small joint thickness of approximately 1 millimeter.
So tightly compacted.
The second...
Again, like even when you compare it, again comparing to British houses, they'll usually use that kind of standard small break and leave, compared to this, a relatively thick amount of the cement in between there. This is like really tightly packed. That must have insulation benefits in itself.
Second row is quickly laid. A barrier film against rising damp comes over it again.
This is like
the two lower rows of stones form the base of the house, which will later be clad.
Really like so high quality
the walls
already.
Are now protruding over the base. The masons are making good progress thanks to the large-scale bricks. But instead of laying row after row now, they first concentrate on the corners of the outer walls.
Yeah, again, with the size of these bricks, which again I've not really seen on many modern British houses, it must make the job quicker and more efficient to actually get done, just because if you're looking at that, I don't know how many normal bricks that would be in the UK. It's like 8, and they're obviously about half the width of that as well. Really like impressive. Again, is this normal? Or is this just a very specific case? Would these be more expensive than normal bricks?
Forming the corners has the advantage that you can easily lay out the plumb lines for the next rows of tiles. The first working day is done.
That's a lot of progress for one day, honestly.
The next morning they continue with the outer walls. The bricklayers place row after row. The windows and lintels are installed. And around noon the bricklayers arrived at the last row on the ground floor. Finally, the pink styrofoam formwork is laid for the concrete ceiling. The formwork also serves as insulation and remains on the building after finishing the ceiling. At the end of the second working day, the outer walls of the ground floor are ready.
That's quite incredible progress. Tell me, yeah, again, is this normal to build a house so quickly in Germany? Again, like if I'm just keep comparing to UK, like they have a reputation for always being over time, over deadline, and so on, and not being anywhere near as efficient as this is seemingly. And where is this? Is this like, does it vary by region of Germany? Tell me where this sort of place is.
Day 3. Today the interior walls are created. Here too, a bitumen membrane is placed under the walls to protect against rising damp. The stones are so-called vertical perforated bricks in 2 different versions. For comparison, here both on top of each other. The brick with 17.5 centimeters wall thickness for the load-bearing walls and the narrower brick with 11.5 centimeters for the non-load-bearing walls. The floor plan shows where which stone has to be used. The load-bearing walls run right through the house, between the living room, guest room, kitchen, and the utility room, and once along to the load-bearing living room wall, and the non-load-bearing walls run between the kitchen, living room, bathroom and the utility room. The walls are set up here just like the outer walls. Cement mortar under the first row, exact leveling of the first stones with laser, from the second row on, thin bed mortar, laser, spirit level, plumb line and constant checking ensure exact, straight walls. Finished. The inner walls are standing. Now the base gets a diffusion open seal before the cladding is coming.
Honestly, it kind of blows my mind how quickly they're doing this. And I'm sure it's going to be of the best standard as well. Like in Germany, I'm sure there's a lot of safety regulations for properties, whether it's the materials, how it's built and so on. So you know it's going to be like of a high standard. And it's like, again, for instance, I've got a neighbour who was doing renovations inside their house, already built their apartment. They were just like, I think they were doing tiling and stuff. It went on for like 4 months or 5 months, drilling every day, noise. We see they're almost building a house in 4 days, and like they can't even like just renovate some rooms inside the house for like months. It's mad, the difference.
Day 4. The scaffolding comes. The base is clad and the masons set up pillars throughout the house to support the ceiling elements. The next morning, exactly at 8 a.m., the crane stands for the ceiling elements. The ceiling elements, so-called semi-finished part ceilings, are approximately 6 centimeters thick reinforced concrete slabs, in which part of the necessary reinforcement has already been inserted. They can be laid quickly and flexibly, depending on the size, but then still need to be concreted. For this, the masons insert additional reinforcement bars. Firstly, to optimally connect and consolidate the ceiling with the masonry. Secondly, to join the individual ceiling elements together. This creates a stable, closed concrete ceiling after concreting. Only the access to the stairs remains free and has to be boarded accordingly. Once all the reinforcement bars have been laid, everything is connected with wire so that nothing moves during concrete pouring. The ceiling openings for the supply lines, water, heating, electricity which comes to the upper floor also remain free. They get polystyrene covers before concreting. Finished. The concrete for the ceiling can come. A total of approximately 12 cubic meters of concrete flow into the formwork for the approximately 10 by 10 meters ceiling slab. It is important to evenly distribute and prevent air pockets. Therefore, constantly push the concrete back and forth, so that the air can escape. The height must of course also be correct and is constantly checked with the laser. Done.
I'm quite amazed by the speed they're working at, actually.
Now the concrete is compacted with a surface vibrator. The surface vibrator directs high-frequency vibrations into the concrete. This increases the flowability of the fresh concrete. Air pockets rise to the surface and can escape. This gives the concrete its perfect, dense consistency. Finished. Now the concrete ceiling has to harden. A few days later, the bricklayers start with the upper floor. The construction is the same as on the ground floor. The outer walls are created again with the thermal brick made of Puritan stone with hydrophobized mineral wool. First the corners are created again, then the entire outer walls. However, there are no longer any load-bearing walls inside. All partitions for the master bedroom, dressing room, bathroom, children's room and corridor are built with the narrower, vertically perforated brick with a wall thickness of 11.5 centimeters. After 4 days, the upper floor is also up. As a conclusion, only the anchor ring plate is missing. For this, the bricklayers have already put a formwork on the top row of bricks, into which reinforcement bars are now being laid. The anchor ring, as the name suggests, runs like a ring around the entire top edge of masonry. This reinforced concrete construction gives the wall stability. The anchor ring plate is used to absorb and transfer horizontal tensile forces such as wind, ground vibrations and the roof load itself. If the concrete is filled, it must be compacted again with the surface vibrator. The masonry work is now complete. The walls of the house stand. Construction time for the 2 floors, 10 days.
That's actually amazing. Is that normal? Like, again, like, this is building a house in Germany. Is this always the case, how quick they can do it? It's using such a high quality like brick, and it's like building it, like I said, like very, very different to how we're getting new homes in the UK. You can tell this is going to last. Good quality, well engineered, well structured, and just the fact they work so quickly and efficiently, so quick to get that job done, man. It's looking great. Tell me, I mean, how much would that cost to build something like that? Is it more affordable to build your own house in Germany? Yeah, tell me what you think about this. Thanks.